Okay, everybody, so what we're going to do today is we are going to look at how to use the resistor color code chart. Now, this is in the PowerPoint that you already have. It's slide 8, so you might want to have a copy of that on your screen handy when you're doing the practice problems or when you're doing the assignment. So on a quiz or a test, I would make sure that you have this. I would not make you memorize this. All right, but we're going to use this example. I'm not going to be flipping back and forth to this. So if you need to pause the video and put this up on the screen, you can do that. All right, so we're going to go right to the example that I made for you guys and use that. So we're going to do two 4-band resistor examples, two 5-band, and then I'm going to do a special one for you, okay? So looking at the chart, if we go ahead and do this resistor, the colors are yellow, violet, orange, and gold. If I look at the yellow, that's going to give me a number of 4. If I give me a violet, that's going to be a number of 7. And for the orange, that's going to be the multiplier because it's a 4-band. So that multiplier is 1 kilo ohms, okay? And the gold is going to be the tolerance in this case, so it's going to be plus or minus 5%. So the final value of the resistor is going to be 47 kilo ohms, and it's going to be plus or minus 5%, okay? So that's example 1. If you look at example 2, this is another one that's 4-band. Okay, so again, I'm going to look at just the colors that are there. I'm going to look at the green, red, blue, and silver. So for the first one, the green, that is going to be a 5. The red is going to be a 2. The blue is the multiplier band, and that's 1 mega ohm. So I'm just going to say 1 mega ohm there. And the silver tolerance in this case is going to be 10%. So that means that our final value in this case is going to be a 52 mega ohm resistor with a tolerance of plus or minus 10%. Okay, so it's pretty straightforward. You just got to look at the bands that you have. And by the way, you always need to make sure that the tolerance band is going to be small. It's going to be kind of separate. It's going to be by itself a little bit. That needs to be on the right-hand side. Otherwise, if you flip it around, you're going to get the wrong reading. You can kind of see how there's a little bit of an extra space there. That's what we're talking about. All right, let's look at the 5-band examples. Okay, I've got 2 of those here for you. So for the 5-band, the first example, I've got brown, green, gray, red, and red. Now, it's a little hard for me to cram that on there, so we're going to assume that the last red is off by itself. Okay, so for the brown, I've got a number of 1. For the green, I've got a number of 5. For the gray, I've got a number of 8. And in this case, the 4th band is the multiplier. And the multiplier is going to be 100. Okay, the red in this case is also the tolerance. Okay, and the number for that tolerance is going to be 2%. So if we go ahead and look at our numbers, I've got 15800 ohms. Now I can also write, if I want to, 15.8 kilo ohms because it's the same thing. So you can write that a couple different ways. And then we're going to have plus or minus 2%. Okay? So that's the first 5-band resistor example. The next 5-band resistor example is here, okay? Blue, brown, green, black, gold. Okay, so let's go ahead and look at the numbers. If I look at the first color is blue, that is going to be a 6. Okay, my brown is the next one. That is going to be a 1. The green is the next color. That's going to be a 5. The black is just going to be a 1. It's going to be a times 1, so times itself. And the gold is going to be 5%. Okay, so if I go ahead and look at this number here I have 615. I don't need to do anything because of the multiplier, ohms, and then it's going to be plus or minus 5%. Okay, so that's pretty much it for the resistor color codes. All right. Actually, take that back. I've got one special example where the reason why this is special is because it looks like it's a 3-band. In some cases, we'll be missing the tolerance band. So that's something special. I just want to make sure that I address that with you guys. Okay. So if I look at the first color in this, I will see I have a white, which is going to be a 9. The violet is the second color. That's going to be 7. The black is my third color, which is 1, okay, and none. I don't have a tolerance band. Anytime I don't have a tolerance band, I have to have a tolerance of 20%, plus or minus 20%. So my final value is going to be 97 ohms, plus or minus 20%, okay? So that's the special case there. Now, the rest of this PowerPoint, or the rest of this video, I'm going to be looking at showing you guys how to find equivalent resistances. That's also something that we need to take care of. If we have a circuit that's in series, and this is the same circuit that was in your other PowerPoint, I went ahead and just copied it and pasted it here. All we need to do is just simply add these numbers together. So to find the equivalent resistance here, REQ is going to be very simple. It's going to be 10 plus 20 plus 30. So I'm going to add those up all together and I'm going to get 60 ohms. So that circuit, the equivalent resistance is going to be 60 ohms. It's very easy. Okay. The next type of example that we have is if it's in parallel. So you can take a look at this circuit here. You see I've got these 3 branches. They're in parallel. Okay. They're each of the branches are parallel to each other. So what I need to do is I've got to find the reciprocal of each branch, add the reciprocals together, and then take the reciprocal of the sum. So now it's easier. I don't like working with fractions. I like working with decimals. It's just a little bit easier for me. So what I like to do, and that might actually be faster for you guys to do in your calculators, otherwise it's a lot of math work there. So what I'm going to do is I'm going to go ahead and take a look at this. I'm going to go ahead and type it out. That way we can figure this out. 1 over 10 plus, sorry about that, 1 over 20 plus 1 over 30. Okay. So what I'm going to do next step is I'm going to go ahead and I'm going to convert those to decimals. So 1 over 10, that's pretty easy. That's 0.1. 1 over 20, that's also pretty easy. That's going to be 0.05. And 1 over 30, that's going to be that's going to be 0.033. I'm just going to carry it to 3 decimal places. Now what I'm going to do is I'm going to add all those numbers together, and that's going to give me 0.1533. Now I'm not quite finished yet. What I have to do is I have to take the reciprocal of that number. So what I'm going to do is I'm going to take REQ, and I'm going to go ahead and do 0.1533, and I'm going to raise that to the -1 power on my calculator, and what that's going to give me is 6.523. Okay, so I think that's the approximate answer there. It's pretty straightforward. So I've got to find the reciprocal, I've got to find the inverse of each branch, add them together, and take the reciprocal of the sum. Now, most circuits are not really easy and nice like that. Most circuits are combinations of the different patterns. So what you have to do with each circuit is you have to look at what you have. And my recommendation is to go ahead and look at, if you have parallel branches, you can see that I have 2 parallel branches here. So I'm going to see that this branch has got 2 that are in series. And I see that this branch has 2 that are in series. So the key thing is here is simplify branches first, then do parallel branches. And if there's any outside of parallel branches, do those, okay? So what we'll do is we'll simplify branch 1. That's going to be 7 plus 11. And yes, I was playing with numbers a little bit. That will be 18. Branch 2, that's going to be 24 plus 12. That's 36. And in the overall, what I'm going to do is I'm going to take 1 over 18 plus 1 over 36. I'm going to convert those to decimals. Okay, and when I do that, I got 1 over 18, that simplifies 0.055. And then I've got my 1 over 36, 0.028. And I add those up together, I get 0.083, but then I have to remember I have to take the reciprocal of that sum because these are in parallel, okay? And then I go ahead and take the reciprocal of that sum and I get 12 ohms, and then I'm finished, okay? So hopefully that was a good few examples for you guys to look at.